All right, in this video we will be talking about the microscopic structure of blood vessels and covering all the terms you see highlighted here. And we'll be covering those terms either conceptually or in this image that you see right here. All right, so overall what we're talking about here are arteries, veins, and then we'll talk a little bit about capillaries here in the middle. If you remember from the anatomy of the heart, we talked about, really emphasized that arteries and veins are different not because of the oxygenation running through them, oxygenation of the blood running through them, but they are different because one of them, the artery over here on the left, is built for high pressure blood. And the vein here on the right is built for lower pressure blood. And so an artery and a vein are they're very similar vessels, but one is for high pressure, one is for low pressure. So what are the pressures we're talking about? Well, think about your blood pressure, right? Like a 120/80 blood pressure. That's an average blood pressure of 93.3 millimeters of mercury. And so that's maybe not the most intuitive measurement because it's in millimeters of mercury, but that's a decent amount of blood. If you think about how hard a blood pressure cuff has to squeeze, like if you put your hand between the cuff and someone's arm, it's actually a decent amount, right? It can even kind of hurt people a little bit. And so that's a lot of pressure traveling through this relatively small little tube that we call an artery. When it comes to veins, though, think about that, how easy it is to collapse a vein. Just look at your hands right now. You can probably see some veins running through them. If you hold your hand down, well below your heart or closer to the earth than your heart, you'll probably see those veins puff up a little bit. They'll fill with a little bit more blood. But no matter how full a vein is, if you find the biggest, toughest vein in your body, you can collapse that easily. With the weight of 2/4, you could probably collapse any vein in your body. That's because the blood inside of a vein is much lower pressure. So what does that mean? Well, veins have thin walls and arteries have thick walls. And in this video, we're going to talk about the layers that make up those walls. So what we're really looking at here are three layers: the tunica interna, the tunica media, and the tunica externa. If you decode that Latin just a little bit and translate it, that's just the inner layer, the middle layer, and the outer layer. Not too complicated here. The inner layer, as you can see up here, is made of two primary things that I want you to know. Endothelium, which is essentially the same thing as epithelium, and it's specifically simple squamous epithelium, but histologically speaking, epithelium only lines external spaces, basically. So in your digestive tract or your skin, we call it endothelium when it's within the body itself. But essentially, it's simple squamous epithelium that lines all your blood vessels. And then that endothelium, I'll try to use the correct term. Endothelium is anchored to the rest of the blood vessel through areolar connective tissue, and that tissue also has a layer name to it. If you remember from histology in week 2 of the first term, it's called the basal lamina. Essentially, you have to glue all epithelium or endothelium down to the surrounding tissue. You do that with areolar connective tissue, and we call that layer of tissue the basal lamina. Then the tunica media, our middle layer. Really, all you got to know about this is smooth muscle, and lots of it for the artery and not as much of it for the vein. But in both cases, you have smooth muscle. Don't think veins don't have muscles. They absolutely do. When you get very cold, your veins immediately constrict to conserve heat and to shunt or move blood to the central regions of your body to conserve heat, basically. And it does that by squeezing on its smooth muscle in the tunica media. It just doesn't need to be as big because the blood pressure is 1/10 to 1/20 of the blood pressure of the artery. So you've got around 20 times more muscle, smooth muscle in the tunica media of the arteries, simply because if you're going to squeeze on an artery, you need to produce a lot more force. Then the tunica externa, it's our external layer. It's also referred to, another name is the adventitia. But the tunica externa is really very structurally important, so it has fibrous connective tissue in it. Areolar connective tissue, remember, that's the glue. And in this case, it's the glue that's essentially holding the external fibrous layer of the artery onto the rest of the layers. And so if you remember from the digestive tract, you always have an external fibrous sort of capsule, like the wrapping, on the outside of a sausage. In this case, this layer is quite a bit thicker than like what's on the outside of the sausage or your stomach or your small intestine. It's thicker than that because, again, you're dealing with a decent amount of pressure, especially in arteries. But this is collagen fibers creating that actual structure, external structure of the artery. All right, that's it for the basic layers. Now the remaining terms are still in here, but some of them are labeled, some of them aren't, and some of the things are a little bit more conceptual. So let's start with these, internal and external elastic lamina. So what you have here, I don't care that you know which layer these are in, because depending on the sources that you check, you're going to get different answers. So that's why it's moved out of the layer section on your list. I just want you to know that these exist. Essentially, you have two very specifically defined layers of elastic tissue called the internal and external elastic lamina. They are like two pieces of bread surrounding the tunica media. So it's like a tunica media sandwich. And so that's the external elastic lamina, which is more superficial. That's why it has the term external. And then there's the internal elastic lamina, same idea. And really, this is a great sandwich analogy because it does look like Swiss cheese in this image. But in reality, it's a little irregular. I don't know that it's so Swiss cheese looking. But functionally, it's important because remember, especially in larger arteries, there's a lot of pressure moving through here. There are waves of pressure. And you want the artery to be able to flex and bend to accommodate those changes. And that most of the flex and bend of arteries are going to come from the internal and external elastic lamina. Interestingly enough, though, you don't have this thick layer of elasticity in the veins. And you could pause the video and try to figure out why. You don't have to, though. Let's just talk about it. Basically, there aren't waves of pressure moving through veins normally, so you don't need to have flexible walls. And so veins, even though they're thin-walled, they're actually much more like a slimy Ziploc bag. So a Ziploc bag, it has a little stretch to it, but not a whole lot. You can tear it pretty easily. And that's kind of what veins are like. Veins actually do tear fairly easily. The problem is they're kind of slimy and not very well anchored to the things around them, so it's hard to pin them down in a way that would ever actually tear them. But they are relatively thin, and they don't have that elasticity that you see in the arteries. And then this is a conceptual distinction here, these two terms, elastic arteries versus muscular arteries. So elastic arteries are arteries that actually don't have, they're special large arteries like the aorta. The aorta is the best example. All areas of the aorta lack the smooth muscle in the tunica media. They don't have it. Instead, they have an extra thick tunica externa. And so they are actually they are elastic, but they do not change diameter. So your aorta does not constrict and dilate. It is just a flexible tube. And we call those elastic arteries. And then muscular arteries are like what you're seeing in this picture down here, what we've been talking about up to this point. They are smaller arteries that do change diameter. And the reason they change diameter is they're the ones controlling where blood goes in the body. The heart's just pumping it out, has no idea where that blood's going. The arteries are the ones that are actually constricting or dilating so that blood goes to where it's supposed to. And those are called muscular arteries. Compare arteries and veins in terms of structure and function. Yeah, we've been doing that this whole video. Hopefully you can give me some information about that by the time you're done watching this video. And then last but not least, capillaries. Capillaries are a third and completely distinct type of blood vessel. They are not an artery, not a vein. They are totally separate, but they are relatively simple because they are your endothelial cells, essentially just wrapped in that same basal lamina, that idea we have areolar connective tissue that glues the endothelium to the surrounding tissue. But it's essentially just a wrapping of basal lamina, and that's it. So it's very, very thin. If you look at this under a microscope, you probably wouldn't even notice this purple layer of basal lamina around the outside, but that's it. You don't have adventitia, you don't have anything like that because you're actually exchanging things. You want the thinnest wall possible with a capillary because you're actually exchanging things between the environment and the inside of your circulatory system. And so you do have a thin basal lamina, but if you remember, areolar connective tissue is very porous. It's not very tightly woven together, and so it allows for basically the filtering of plasma into the interstitial space, and that's when we start calling it interstitial fluid. So don't think this big purple thing is like a sealed wall, because that wouldn't make sense because capillary beds are for exchange. So in reality, it's just a very, very porous layer of areolar connective tissue that helps maintain the structure of the capillary bed. That's it for this video.